I have been asked a million times about the DevOps project, and I am bringing the DevOps project in this video, where we will be deploying an end-to-end application onto a Kubernetes cluster with HTTPS and GitOps using GitHub Actions and ArgoCD. For HTTPS, we'll use Cert Manager and Gateway API, and for the 0CB base image, we'll be using BuildSafe. For Kubernetes cluster creation, we'll be using Ksctl, and we'll also be doing load testing using Ksctl. And this is how we'll be deploying an end-to-end project onto a Kubernetes cluster. I hope you are excited as I am, and hope you like this video. So make sure to subscribe to the channel, and let's get started building this awesome DevOps project. So what are we trying to achieve today by creating this DevOps project, and how we are going to do this? So we'll be having a repository created for this particular project, and that will be a simple GoLang application. Now we have to build the artifact in order to deploy. The artifact that we are going to build and the image that we are going to build will be built using BuildSafe and KO, so that we can achieve a 0 CVE image that we can deploy onto a Kubernetes cluster. And that will be pushed to a OCI registry. For now, we'll be pushing it to Docker Hub. The GoLang code will be able to connect to a Postgres database, and we will be deploying the Postgres database onto Kubernetes cluster using CloudNativePG. We'll also be instrumenting the GoLang application using Prometheus SDK. Now, when we will be deploying the application, we'll be creating the cluster using a tool called Ksctl, which will be an AKS cluster. And then we'll be deploying some of the components in order to get the application ready, because we want HTTPS. So for that, we'll be using Cert Manager and Gateway API. And we won't be needing ingresses, of course. And it also carries a lot of other functionalities rather than a simple plain ingress. We'll also then install Grafana and Prometheus, because we want to scrape the metrics that we have instrumented for the application. And then we want to visualize that as a Grafana dashboard. We will be doing some load testing and create a HPA so that we can see if the load comes in suddenly, then the application is able to handle that. In the end, we'll do all of the GitOps stuff, which means we'll be deploying ArgoCD onto the Kubernetes cluster. Again, HTTPS using Cert Manager and Gateway API. And then we will be having the CI, which is the continuous integration for the application using the GitHub Actions. So that is how the complete end-to-end DevOps project would look like. Now, I know you are really excited. So without wasting any time, let's get started in building this amazing project. Before that, make sure to subscribe to the channel, press the bell icon for the amazing videos, and keep sharing. So let's first start with the application itself, what the application is and what it does. So this is the main.go file. In that, it's a simple GoLang application. First is the import. So these are the packages that we intend to use in the application. For example, we want database SQL, we want FMT because we'll be using that. We want log, we want net HTTP, and we want OS. And we want gen. So you can think of it as Flask that you use in Python. So that's a gen module that we are using here. Prometheus, GoLang client, and also Prom HTTP from that. And then PQ, which helps make Postgres work with the database SQL. So this helps the Postgres to work with database SQL. First is we are defining the Prometheus metrics. This is for the instrumentation of the code. So we have created 3 types of metrics: add goal counter, remove goal counter, and HTTPS request counter. In that, we are creating new counters, and we are giving it a name: add underscore goal underscore request total, remove goal request total, HTTP request total. So these are the 3 new counters that we are creating. Next is registering the metrics. So this is how we are registering all the 3 metrics that we have created above. Next is the create connection function that creates the connection with the database. So we are in this particular case, we are getting the stuff from the environment variables, where we are getting the username, password, host, port, DB name, SSL mode. And again, these are some of the errors, like if it's not found, or if the connection string is broken, then it is in error state. Now comes the main function. So we define a router with gin.default. In that, we are loading the HTML glob and we are getting it from the code data path where we have the index.html file. So that's the simple index.html with CSS. And here we have a few form actions, like we have a form with the action of like add goal, and then on submit, like it goes, and same is for the remove goal. And this is how it is handled in the main.go file. Let's continue to see how that happens. We create the connection. So that's creating the database connection. And then these are the routers. So once we hit the slash, what it does is it queries select star from the goals database. So there is a database that it is trying to fetch the rows from, and that has int and ID and the name, and it is appending that to the goals variable. And here we are increasing the counter for the Prometheus metrics so that we are aware that this particular function has been called. And then we are setting it to the index.html goals, and we are passing the goals, and here it is getting the goals, and it will be able to show that. You can see this in the goal list. So it is range goals, and then it is able to show the name. And then when it shows the name, there will be another form where we have an option of remove goal, and then it is removed by goal ID. So how it is being done is when we go to the main.go, now first the add goal is again the goal name. From the post form, we take the value of the goal name and we do a simple insert query of that goal name into the goals database. And we increase the counter for the Prometheus metrics. Same for the remove goal. We take the goal ID from the post form, and you can see over here, the post form, we are getting the ID, goal ID. And that is the exact value that we are taking from here, which is the goal ID. And now we are doing a simple query after creating the connection. The connection is already created. So we are executing the query of delete from goals where ID is this. And then we are incrementing the remove goal counter as well. And then we have a small health function that just returns OK. And then we have the router get metrics where we are passing the prom HTTP handler and everything is running on port 8080. So that is a simple GoLang application that is handling a bunch of routes, and it is having a simple HTML page. Pretty basic, simple application that is doing meaningful things and accessing and adding to the database as well. So we have a front end and we have a interaction with the database over here as well. So our GoLang application is there. Now what to do? So all the code and all the files and all the steps will be there in the link to the repository below that I have mentioned in the description. So the first step that we need to do is we need to build this and then run it locally. So how to build this is we need a base image. So for that, we can either use any of the base images which are available, or we can create our own base image, and we like creating our own base image. So for that, we'll be using a tool called BuildSafe. If you don't know about BuildSafe, BuildSafe is a CLI tool that helps you create 0CV base images, and then you can use that in your Docker files or as part of Jib for Java or Co for GoLang. And in this, we are using the combination of BuildSafe and Co. So BSF init. That is the first thing that we will be doing. So it is asking, do you want to create a base image? We say yes. What should be the name of the base image? So we say SIEM911, which is my repository name, like in the Docker Hub, and we'll give DevOps Kube project. Would you like to add common dependencies like compiler, linter, debugger? Yes, let's add that. Which common dependencies would you like to add? Obviously, it's a GoLang application, so Go. Now it is resolving the dependencies and creating some of the things. So it has initialized, and under the hood, it is using nginx. So that's why you will be able to see some of the BSF things, which is BSF HCL, BSF folder. In that you have flake, flake.nix, and the default.nix. You don't need to worry about any of these things. If you do not know nix, it's completely fine. And if you want to know more about BuildSafe and how it works, then there are a few videos on Kube Simplify already available to go deep dive into BuildSafe. Let's look at bsf.hcl file that got generated. And we can see that it has some of the packages as part of the development environment and only one for the runtime environment. And the OCI packages for the name, it is the DevOps Kube Proj. And we can give CMD, entry point, env vars, which we don't need in this particular case. So now what we'll do is we'll build the base image. So for that, we'll be using PSF OCI packages, platform Linux AMD 64. And we'll tag it as the base image because this will be the base image and push it. For the destination creds, I'm using my Docker Hub credentials where my username is Sayam911 and password is hidden. So I've just set it as the environment variables before actually running this command. So the artifact has been created and has been pushed. Let me now go to the hub.docker.com to see. And we can see 1 minute ago, DevOps Kube project has been pushed to my Docker Hub repository. Okay, so now we have the base image, but we don't have the application build yet, right? So what we do now is we use a thing called KO. So KO makes building Go containers image easy, fast, and secure by default. So it is simple image builder for Go applications. And it is ideal for use cases where your image contains a single Go application without many dependencies on the OS packages. And it generates SBOMs by default. And it's also a CNCF sandbox project. One of the things that we are also using in Go is static assets because we have stable index file. So Go can bundle those static files. It has to be in the Go data path. So which is the reason we have this Go data directory created in the home of this particular project. And that is where we are using the Go data path inside the GoLang application as well, which is also mentioned in the repository that you have to use the Go data path environment variable. And that's how you'll be able to get it, which is what we are actually doing for the gin. Now the main image that you have to deploy onto the Kubernetes cluster is the Sayam911/DevOps project. Here I want my application to be there. I want it to be tagged as v1. So I define inside the Go Docker repo and the Go default base image. So this is the base image that we have to use, which was created by us before. So we'll be using Sayam911 DevOps Kube project base. And then we are just building it. So it has built and pushed the application. Let's again go back and go to the repositories. And we can see in the DevOps project less than a minute ago, we have a new tag a few seconds ago. One is V1 and one is the SHA digest manifest that it automatically creates. What we can now do is the most interesting part first, before we actually deploy this application is, we need to test if this application is 0 CVE. That was one of the first goals, if you remember, in the diagram that we are building the application using Go and BuildSafe and getting the 0 CVE. So we'll do gripe and give the image name. Gripe is able to scan a particular image and tell if there are any vulnerabilities or CVEs attached to that. And we can see no vulnerabilities found in this particular image. How cool is that? Because this is the application that we will be deploying onto the cluster. But wait, before deploying to the cluster, let's see how that works. And let's see if you have a local environment and you have Docker installed, how you can actually run this whole project and how you can replicate everything mentioned over here. Obviously, apart from the HTTPS gateway API and stuff, because you are doing it locally, but how to replicate it in a very simple way. So we'll deploy everything as Docker containers. So first, we are deploying Docker run Grafana and we are using the Grafana image. Second, we need Prometheus. But in order for Prometheus to scrape the metrics, what we are going to do is we are going to use this Prometheus.yaml file. So in Prometheus YAML, you can define the scrape interval and you can define extra scrape configs. This means that Prometheus will look for this particular target. So it will look for host Docker internal 8080. So our application will be running on 8080 and Prometheus will be able to scrape the metrics on /metrics endpoint from this application. And we have exposed that endpoint. So let's do Docker run -n Prometheus port 9090 and give the Prometheus YAML file, put that in the Prometheus and run the Prometheus image. Obviously, our application needs a Postgres, so we need a Postgres. So Docker run Postgres, and with that, we are giving a Postgres user, a Postgres password, just a dummy one, and a Postgres database and the port and stuff. So this is there, but do you remember that inside our GoLang application, we are using a database called goals, and we have an ID and name attached to that. So we need to create the database and the table for this. So let's do that first. Let's exec into the Postgres pod and create the table. So create table goals with ID as the primary key and goal name as text. Exit it, and now we'll be running our application. So in our application is reading the environment variable, as you can see. So it is expecting the environment variables, and we are passing that when we are doing Docker run. We are passing the password and the DB host and the port, the database name, SSL as disable for this because it won't work otherwise locally, and the image that we just built. So this is the application. Now if we do Docker PS, we'll be able to see our project is running on 8080. This is the Postgres database, this is the Prometheus, and this is the Grafana. So let's try out everything and see it in action. So localhost 8080. This is the application. Kube Simplify viewers, you are awesome. So let's enter the goals. One of the goals is learning Kubernetes. One of the goals is learning DevOps. And one of the goal is reaching 1 million audience. For me, that's for me. Well, so we have added 3 goals. It should have added in Postgres. Obviously, everything is working, else it would have thrown the error. Let's try to add the Prometheus source in the Grafana. So let's open this. The default one is admin, new one. And this is a simple Grafana dashboard. So Prometheus is actually a time series database, and it's a monitoring solution. And it is kind of a standard that is deployed when it comes to instrumenting the application. Yes, OpenTelemetry is also there. You can use that. But for now, we'll be using Prometheus as standard for our database, for our time series database that we are storing the metrics in. And then for the visualization, we are using Grafana. Grafana is a visualization tool where we can add data sources. So that's what we are trying to do. We are trying to add the Prometheus data source. And here we'll be giving host Docker internal 1990, where the Prometheus is running. We are saving and testing, and we see that it has successfully queried the Prometheus API. Now we go to the dashboard, we create a new dashboard, we add a visualization, we select the data source, and now we will be selecting the metric. For our metric, we have added 3 goals, and we'll run the query, and we'll see here that there are 3 goals added. So that's how cool it is. So we have actually implemented and executed all this locally using Docker. Now is the time when we switch gears and deploy it onto Kubernetes. And for the database, we use CloudNativePG. And for HTTPS TLS, we'll be using Gateway API and Cert Manager. In order to deploy to Kubernetes, first we have to create the Kubernetes cluster. And for this, we'll be using a tool called Ksctl. So Ksctl again started off as a community project as part of Kube Simplify. Now it's independent under its independent organization, and it lets you create and manage the managed Kubernetes clusters and the highly available Kubernetes clusters across cloud providers. For this particular case, we'll be going with AKS, Azure Kubernetes Service, but everything should remain the same irrespective of which cloud you are deploying to. So I already have Ksctl installed, and I'll do Ksctl create cluster, the provider Azure, and the name DevOps project with version 1.29. So basically, if you want, you can add more parameters, like you can give different type of specifications, the node type managed, which size you want, Kubernetes version, number of nodes. And also there is a step where you can create credentials. So I already have the credentials stored as part of Ksctl, but you can do that Ksctl cred. So you will be able to add the subscription ID and the secret. So with this, you can add the credentials that the Ksctl CLI will be using in order to create and interact with the cloud provider for creating the AKS cluster. So I haven't even touched the UI. And you can see that it is already creating a cluster and in a new group, and it is creating the cluster, and the cluster should be ready in a few minutes. Till the time the cluster is getting created, let's look at some of the files that we will be deploying onto this particular Kubernetes cluster. So in order to deploy to Kubernetes, by the way, if you are not aware of Kubernetes, then I have a full-fledged Kubernetes workshop that you can check out on Ksmplify YouTube channel to learn all about Kubernetes. And if you also know Hindi, so I have a Kubernetes boot camp in Hindi as well. So in order to deploy our application, the first step that we do is we create a deployment. So deployment is a Kubernetes object. In this particular case, we are creating a deployment, and we are specifying the name of the deployment as my app, giving a label app, my app. Labels are important. And in the replica section, we are saying 3 replicas for high availability. And in the selector, we are matching labels app, my app. Now comes the template section. The template section are for the pods that will be generated. So pods will be getting this metadata, and the spec section of the containers, we are specifying that the image that we just pushed to the Docker Hub registry, SIEM 911 DevOps project v1, image pull policy as always. Now we have specified like our application expects reading some of the variables in order to create the database connection as environment variables. So we are passing those environment variables. We are passing the database username, and the value it should be taking from a secret key. So we will be creating a Kubernetes secret with the name of Postgres credentials, and in that we'll be giving a key as username. We will be specifying the username, and the same for password. For the host, we will be creating MySQL Postgres read write default.spc.cluster.local. It is known because I know this will be created because of the Postgres cloud native Postgres cluster that will be created. DB port and DB name is goals database. In the port section, we define container port 8080 where our application is listening. And if you remember, we have a /health as well in the main.go file. So if you scroll down in the end, you have a /health, which is the health check that we are using in the deployment for the readiness and liveness probe. And we are also specifying the resource request and limits for memory and CPU. After this, we are specifying a service. So we want a API version kind service, labels app, my app, so that it can select those pods and add them as endpoints. In the ports, we are saying this is on port 80 and targeting to the container port 8080, and this is the type of cluster IP. The next two things are gateway and route, which I will be explaining a bit later on when I first explain the concept of gateway API. So, okay, our cluster is up and running. What we are going to do next is get the credentials, the kubeconfig file, and expose it as kubeconfig variable. So, Ksctl switch cluster provider is your region East US name DevOps project. It says the kubeconfig file is saved here, so you can export that variable. Ksctl get nodes, and we can see a single node cluster is up and running. Ksctl get pods -a. It already has some of the basic pods that by default comes with the managed Kubernetes for AKS. Okay, now we will go step by step. First step is to install Cert Manager. Cert Manager is a project that we will be using for the certificate, like issuing the certificate, renewing the certificate, making sure it is properly solving the challenges as per the solvers mentioned inside. So for that, we'll be using Cert Manager. And it's a very simple command, Ksctl apply from the Cert Manager documentation that we are using. It will create a bunch of CRDs and stuff, and then a deployment for the Cert Manager in order. And then we should be able to create stuff like cluster issuer, certificates, and we can check if the certificates are true. And we can also specify the resolvers to be used. So Cert Manager stuff is created. These are the major components. And obviously, we have the Cert Manager custom resources created as well, custom resource definitions. The next step is to edit Cert Manager. Now, before that, I want to explain the concept of how we will be actually getting HTTPS.
So for our service to work and communicate with external, like for example, there is a person who wants to access the application, how they will be able to communicate and how the traffic will take place. Earlier, mostly people were using ingress. So people install ingress controller and they create a Kubernetes native object called kind ingress. And that request first goes to ingress, and from ingress, it goes to the service and the pods, and traffic is served that way. But it has certain limitations because most of the things like traffic splitting or header based matching routing and some of the other capabilities were annotation based only, and it was not in a specified structured way. So you can say that Gateway API is a official Kubernetes project from SIG Network, and it is mainly focused on the L4, L7 routing in the Kubernetes. It actually represents the next generation of Kubernetes ingress, how load balancing should work in Kubernetes, and the service mesh. So it is basically comprised of three things, which are gateway classes, second is the gateway, and third is the routes. Now, Gateway API is role oriented, so means there are specific stuff that is specifically intended for a particular role. What that means is, let's say there will be a infrastructure provider. Now, infrastructure provider will give you a gateway class. Now, gateway class can be compared to storage class or ingress class that is natively available. Like, it might not be available now, but it is kind of natively available. Think of it that way, like whosoever will provision the cluster will give you that gateway class. As the operators, cluster operators, they create the gateway. So gateway is the way that tells you how the traffic flows to the services. So that is the gateway. And third is the application developers, like who are developing the applications, they will be creating the routes. And routes will be how the gateway to the services are mapped. Now the specification is written in a way that it's portable, and there are numerous implementations for Gateway API as well. So Gateway API also lets you do out of the box traffic splitting, traffic weighting, traffic splitting, header based matching, and all those which I told you are possible only by the annotations in the ingress. So gateway class gives you the load balance and implementation, and then you have the typical gateways that the cluster operators create, and then you have the routes that are created by the application developers. There is experimental service mesh support, which is called as a Gamma initiative within Gateway API. So that is why Gateway API is powerful, and it is the way to go in future for routing the traffic from the external users or your external users into the Kubernetes cluster. So in order to do that, there are two things that you need to create. I mean, there are a lot of things that you need to do. First step is to edit the Cert Manager. So there is right now when you install Cert Manager, it is not natively integrated into that. So you need to enable Gateway API in the Cert Manager deployment. So we'll do Ksctl get deploy -n Cert Manager, and we will edit that deployment. And just below in the arg section, we will enable the Gateway API. So that's what we'll do. We'll save this and we'll do a rollout restart for the Cert Manager deployment. Now we have configured our Cert Manager to be able to accept the annotations that we'll be giving inside the gateway and read that and create the certificate automatically. The next project that we'll be deploying is nginx Fabric. So nginx has a project called nginx Gateway Fabric that provides an implementation for Gateway API using nginx as the data plane. It is also a very active project, and it is V130, and a lot of stuff is being added into this particular project. So make sure to check that out, and we'll be just following the quick start guide. So we'll just do a Ksctl customize and install the 1.30 version, and it will create the custom resource definitions. Like you can see, we can create the gateway classes, gateways, gRPC routes, HTTP routes, and the reference agents. And the next is the Helm install of nginx Gateway Fabric. So Gateway API Fabric is now deployed. We can see Ksctl get pods -a, and we can see in nginx Gateway, we have the pod up and running. And also we have the Cert Manager pods up and running. We have a couple of Ksctl pods which are running. Now let's move on to the next part. Right now we have just created the cluster, installed Gateway API Fabric, and we have installed the Cert Manager. But what we have to do is, in order to deploy the application, it expects the database. So we will be installing a database. And that database is CloudNativePG. So CloudNativePG helps you run Postgres inside Kubernetes in a production-ready scenario. It doesn't use the regular stateful set that you might be thinking is the most efficient way of creating the databases on Kubernetes. So Kubernetes became so popular because of its extensibility. Like, it is extendable and people have extended it to a lot high level where people are able to use it in production. And that is why people are actually able to use it in production. So CloudNativePG is a set of controllers and that runs and manages the Postgres pods, not as stateful sets, but something they have mimicked as stateful sets, plus added a bunch of other things that this particular Cloud Native Postgres can do. For example, when you create stateful sets, you have to manage the replication between the pods. You have to manage the backup support. And with Cloud Native PG, what you can do is it's autopilot. So it automates the steps and data is persisted. Security and TLS is managed. It is highly available. The backup and restore is out of the box provided. Monitoring is out of the box provided. So you can specify the update strategy. It is self-healing. It uses Kubernetes API for highly available architecture. It automatically lets the app connect to the primary instance, automatically takes care of the replication, automatically takes care of making it read from one of the read replicas. So yes, stateful set gives you some of the benefits, but what Cloud Native PG has done is it has taken it to the next level, and it is a custom operator which helps you create Postgres and run Postgres database on Kubernetes in a production ready way. So we will do that next. Again, things are from the docs and you can follow along the commands present in the GitHub repository. So Ksctl apply, and we are just applying the Cloud Native Postgres. It is creating a namespace, creating bunch of custom resource definition, config map service deployment, and all those things. So in order for it to understand the Postgres database that we will be creating next. So what we'll be doing is Ksctl get clusters, and right now there are no clusters. So we have a Postgres cluster, and you can see I want to create a cluster named my Postgres. In the default namespace, I need 3 instances of 1 gigs each. And for the init DB, I give certain specification and the secret key. So we'll be creating that secret as well. Ksctl apply -f pg cluster. Now the controller will automatically detect because the custom resource is created, and the controller will read that and do the necessary steps in order to create this. So Ksctl get pods. You will be able to see things coming up in the init phase. And the next step, as I mentioned, is to create a secret. So we are creating a Ksctl create secret generic my Postgres credentials that was used, and we are creating a password and a username, and then just applying that. Now we'll wait for the Postgres database to come up. So the Postgres database is up and running. Now we are executing into it and altering the user with the password. The next step is to obviously create the table. So Ksctl port forward, and then in a new tab, we try to go inside and create the goals table with the serial key ID and the goal name with varchar. So the table is created. Another thing to create is the Postgres credential, which is used by the deployment file. So we need to create the Postgres credential. Cat uf Ksctl apply -f, and we see in the secret we give Postgres credential with the username and password. Ksctl get secrets. And now is the time we see the next 2 things which were left in the deploy.yaml file. So the first thing is the gateway. So in the gateway, we are specifying that we want to create a gateway. And the name of the gateway is app gateway. We are giving the annotation that it should use a cluster issuer let's encrypt pod in order to issue the certificates. So let's create the cluster issuer. And I can just show you the cluster issuer. It's pretty simple. It's with the name let's encrypt prod. It gives you the Acme server URL. The email, the private key reference would be let's encrypt prod. The challenge would be HTTP 1 and the gateway HTTP root with the parent ref, and we have to specify the kind gateway, name app gateway, and the namespace default. So this is what in the solver section we have to specify while creating the cluster issuer in order for it to understand and issue certificates on the basis of annotation specified in the gateway. Let's move back. Gateway class name. So we can check Ksctl get gateway class. It has already created a nginx gateway class. So that was automatically created when we installed the fabric, nginx fabric. Now comes the listener. So what we are saying is any traffic coming from star.kubesimplify.com should be allowed routes from all namespaces and terminate, and the certificates should be issued where the secret is app kubesimplify com.tls. And the next step is the HTTP root. So what we want to do is we want to use the parent ref name app gateway in the default namespace. So we want to use the above gateway, and we are defining a rule that if the host name that the traffic comes is app.kubesimplify.com, then let it go to backend ref my app service and the path prefix is /. Now let's apply this. Ksctl apply -f deploy deploy.yaml. It should create the deployment, service, gateway, and HTTP route. So Ksctl get gateway. It is true and it has given us this address. We'll use this address and we'll put that beside app.kubesimplify.com in our DNS. So let's do that. So I'm editing this. I'm also adding one more, which is Argo, and changing that too, because we'll need that later on anyways when we deploy ArgoCD. Now let's clear the screen. Ksctl get certificate, and we can see the certificate has been automatically created. So we didn't create the certificate, which means the annotation or the argument of enable gateway API that we put worked, because we have put that in the gateway and it has at least issued the certificate, like created the certificate. Now it will do the challenges and the certificate becomes ready in some time. Moving on. So we can see the application is running. The certificate is now true. And if we go to app.kubesimplify.com, that's a HTTPS application running using Cert Manager and Gateway API. So again, we'll add some goals: learning Kubernetes, 1 million subscribers. And we'll also kind of refresh this a bit so that we are hitting and we are trying to get the metrics for this. Obviously, talking about the metrics, the next two steps are installing Prometheus and Grafana. The best way to do that is installing the Kube Prometheus stack. So there is something which is called Kube Prometheus stack. And this will install everything out of the box, like Grafana, Prometheus operator, and it will create a bunch of resource monitors and stuff like that. So we'll do Helm repo adding the Prometheus Helm repository, Prometheus Helm chart, and then installing the Prometheus Kube Prometheus stack in the monitoring namespace. So it will create a monitoring namespace, install all the components inside the Kube Prometheus stack, which is Grafana, create a bunch of service monitors for us, which I'll explain what they are, and then you are all set to visualize the metrics from your pods, nodes, cluster, and get the whole visualization over there. And then we'll configure the custom metrics that we need to scrape from our application. And the Kube Prometheus stack is deployed. Ksctl get pods -n monitoring. And we can see Alert Manager, Kube Prometheus Grafana, Kube State Metrics, Prometheus Operator, Node Exporter, and this is the Prometheus server, which is up and running. Now we will create a service monitor. So what is the service monitor? In order for Prometheus to scrape the metrics, and since we have the Kube Prometheus operator available, So what we can create is we can create a custom resource called service monitor. It monitors a particular service and scrapes a particular endpoint. So the service monitor is created in the namespace monitoring. It has the release label. This is very important. It is selecting the match of the service. Now this has to be app, my app, the exact label in the service and exact namespace where the service in. And it is scraping the endpoint HTTP port with the /metrics path. And if we see the deploy.yaml, we are able to see in the service, we have defined port name as HTTP. So that is what it is scraping. So Ksctl apply-f service monitor. It should be created. Now is the time when we try to check and go in the Prometheus to see if we have all things configured correctly. So we'll do a port forward of the Prometheus service. Let's go to localhost 9090 and we are able to see the graph. Let's see the targets, and in the targets we are able to see service monitoring app my service monitor target appear. So that means Prometheus is able to scrape that metrics. And if we type the metrics that we specified, let's go to our main.go, and I think we specified these 3 metrics. Add goal or just HTTP request total. So let's use that. HTTP request total, execute, and we are able to see that we have certain activities over here. So /health is being checked by the probes, the liveness probes. We have /endpoint, which we hit twice, and we have add goals as well. So we have added a few goals which are appearing over here. So our metrics is properly getting captured from all the pods in the service. Next is visualization in Grafana. So we can log into the Grafana dashboard. So we'll do a port forward of the Kube Prometheus stack Grafana service and go to localhost 3000. Let's log in, and we can see that the secret to log in is Ksctl get secret, and we are just putting a JSON path and getting the data of admin password, which looks to be prom operator. So we are logged in to the Grafana dashboard. Now we'll try to add the data source, Prometheus, and the Prometheus server URL is automatically configured. So we have been able to test it successfully. Now let's build a dashboard. So let's add a visualization from Prometheus and the metrics, add goals, request total. We'll add this one first. Let's run the query, expand this. And what we'll do is we will try to add another value of hello and Kube simplify, a couple of others. So we should see the number of requests rising inside the Grafana dashboard. And we can see the add requests going on from different instances over here. So we can see 6 over here, and we can also see 6 over here. So that's how you can visualize the custom metrics that you have exposed, instrumented from the application. The next part is for CI/CD, for which we have to deploy ArgoCD. Again, from the docs, Ksctl create namespace ArgoCD and just installing the Argo project manifest for the stable version. So it will be creating all the custom resources and stuff like that. And after that, we will be editing the gateway and the route in order for this to also get HTTPS. Now, ArgoCD is a continuous delivery tool. It's a CNCF project, and it lets you monitor a particular repository, a GitHub repository, just in very simple terms for what we'll be using here. So you can monitor a particular folder or particular directory of a repository, and any changes made to that will be applied onto the cluster in very simple terms. So Ksctl get forwards -a, we should have everything up and running. And now let's look at Argo gateway, what we are trying to do over here. So we had earlier a gateway, and this particular portion is same, app.kubesimplify.com, app.kubesimplify.com. So it was not star. We have to use specific domains, and the TLS mode is terminate. Now, in order for ArgoCD to work with HTTPS, we actually needed pass-through, but pass-through TLS mode is not supported in nginx fabric yet. So we'll be using terminate itself, but we need to patch the config map and restart ArgoCD so that we can have that insecure thing true, and it is required for this to work. So for Argo, what we have added is Argo on port 80, HTTP, HTTPS, protocols, namespace all, and Argo secret. So this is what we have added extra in the gateway. So we'll patch the ArgoCD CMD parameters with data, and this is very important, server.insecure true. So ArgoCD restarted, and now let's apply the Argo gateway, and we have to create another route. So we have a route Argo, which is a new route that takes host names like request coming in from argo.kubesimplifier.com matches and goes to the backend ref of ArgoCD. Ksctl get certificate. It should start creating the certificate. Certificate is already true. Now let's go to argo.kubesimplifier.com. Now we are getting 500 internal server error. Let's try to debug and see how to fix this. So we can see Ksctl get gateway. Everything looks fine. Ksctl get HTTP root. Everything looks fine. Let's try to see if anything is wrong with the Argo root. And we can see that the backend ref is not permitted by any reference grant. So we need to create a reference grant as well. And if we go Ksctl get crd grep reference, we'll be able to see reference grants can be created for gateways. So we are creating a reference grant, Ksctl apply -f reference grant. So this reference grant is allowing the namespace ArgoCD, like from HTTP root in the default namespace to the service Argo server CD. This should hopefully fix this particular error. Let's go back. And yes, we are able to see ArgoCD UI. Now let's log into ArgoCD, and hopefully we should be having a secret in ArgoCD namespace for the secrets, and you can see the initial admin secrets. So Ksctl get secret, ArgoCD initial admin secret, and we can just do echo base 64 decode, and that's the login admin, and we are inside ArgoCD. So that is the ArgoCD. Okay, now we have ArgoCD deployed. Now let's push everything from this repository to our GitHub repository, and we'll see a GitHub action over there. And the code is successfully pushed. Now let's check our DevOps project. So inside kubesimplify, we have DevOps project. We have a pipeline which has already started running. What is there exactly in the pipeline? Let's check out. So we have a build push YAML. So this is a GitHub Actions, which I'm using for the CI. So for CI, we can use GitHub Action. So it says on the push to the main branch, it triggers a job, which is release co. If it contains a commit message, head, skip CI, that is when actions will actually commit. It will skip the CI, else it will go in loop. Runs on Ubuntu latest, checking out, setting up Go 122.5, setting up Co. So this is the Co build setup that it is used, specifying the version, log into the Docker Hub. For this, you have to create a secret. And for secrets, you can actually go to settings, secrets and variables and actions. Now here you have to add Docker username and Docker password. Once you have this, you can use that secret, and you can use co-login docker.io to log into that repository. Then I'm getting the SHA shot from the head, because for each commit, there has to be a separate image, that tag that has to be pushed. So core data path specified, core data repo specified, core data default image specified, and run co build where with the tag of SHA and the SHA from env.sha short. Now it is actually using a deploy.to file, a Jinja template. So this is the Jinja template. So inside a TMPL folder, there is a deploy.j2. J2 is the extension of Jinja. Everything is same. Just the thing that gets changed over here is I have given in this braces as the image deploy tag. Means I want to replace this. So I'm using a Jinja template action that says inside this particular file, replace image deploy tag with the sha short, and the output file should be deploy.yaml. And then we are pushing that into GitHub using GitHub Actions. And you can see the push manifest to the repo. So let's see if this particular action was successfully updated. Yes, you can see 2 minutes ago, this was updated. Let's go back to ArgoCD, create an application, give an application name, DevOps, project name, default, sync policy can be automatic, self-heal, prune resources. There are a lot of sync options. We'll keep it simple. We'll do auto create namespace if required, and then repository URL. So let's give the repository URL, and this is the repository URL. It is the main branch, and the path is deploy. So inside deploy, whatever changes, you have to deploy that. And right now it's in the default namespace. So let's create this application. Now, as you come back to the ArgoCD dashboard, you'll be able to see the DevOps project. It is in healthy and synced state. And you can see it has created the service, the app, gateway, root, and you can also see the deployment has created a replica set with 3 replicas, endpoint slice, certificate has been created by API gateway, and the pods are in healthy status. There is a lot more to ArgoCD, but we'll not go into the depths of it. So this is how you can actually create the CD for your application. Now, any change that happens to the DevOps project, for example, if we change the HTML file, so we go to the core data index and we say Kube simplified DevOps project completed, and we commit the changes, it will automatically trigger the CI and the new version of the application should be deployed. We can also go and check, see that the deployment has been updated onto our Kubernetes cluster and it's up and running. And in some time, what will happen is once the CI is complete, we'll be able to see that there is a new image that gets pushed. And as soon as the new image is pushed and the last step is performed, there will be a change in the deploy.yaml file. And our Argo CD is actually watching the deploy folder, deploy.yaml file, the deploy folder. So when it changes, it will automatically start syncing the application with the newer version and the change that happens in the deploy.yaml file. And you can see this is done. So let's go to the application and you can see it was out of sync and it's progressing. It's creating the replicas. And if we go back, we do Ksctl get pods, we should be able to see the new pods are getting up. So you can see new pods are getting up. And if we go to app.kubesimplify.com, we should be able to see in the heading, right now it's Kube Simplified DevOps project. So it should come as the DevOps project completed. So let me refresh it. And you can see Kube Simplified DevOps project completed in the title. Now, the last part that we are going to do is we'll do a load testing. For load testing, we'll use a tool called Ksctl. So Ksctl is an open source tool by Grafana. So it's a load testing tool. So the best developer experience for load testing. Pretty simple. And you can write tests in different languages like JavaScript and stuff. And there is a simple test that I have written, load.js. So here it tries to hit app.kubesimplify.com and it is using K6, and then it is trying to check the responses and doing the requests. So in order to run this, we have to just use K6 run load.js. So it has starting to hit it. And in the meanwhile, what we can do here is Ksctl get pods, and we can watch the pods. So as it is putting the load, we have right now nothing will happen. But what we can do is we can apply a HPA to that. So what does that means is it is a horizontal pod autoscaler. As soon as the average utilization of the resource, so this captures the metrics, resource metrics of CPU utilization, and average utilization as 20, and the resource for memory is 350. So once it exceeds this, so it will scale the replicas between 1 to 10. So let's apply Ksctl apply -f HPA, and now let's do Ksctl get pods -watch. If it doesn't happen right now when the test is running, we'll rerun the test. And you can see that it has already started to create the pods. And again, and sometimes it goes back to 3 because in the deployment we specified 3. In any case, this is the HA1. So usually if you just have a single pod, you can have a single pod and you can have a HPA created, and it will automatically scale up, scale down based on the load which we have created using K6. So that's pretty much it that I had to share with you for the DevOps project. In this project, what we have done is we have created a GitHub repository with GoLang application and instrumented the application using Prometheus. We ran it locally using Docker containers. First, we built the image, use a 0 CVE image, and that we did using BuildSafe and KO. And we pushed that to Docker Hub. We created a Docker container for Postgres, for Grafana, for Prometheus, and for our application. And then we were able to successfully run it. For the Kubernetes cluster, we created the Kubernetes cluster using Ksctl on AKS, Azure Kubernetes Service. After that, we installed some of the tooling. First, we installed the Cert manager. We configured that in order for it to understand Gateway API. Then we installed Gateway API CRDs and stuff. Then we installed the secrets, created the secrets which are required for the database for our application, for the environment variables, and also for the cloud native Postgres. So we install cloud native Postgres. We also install the Kube Prometheus stack, and then we deploy the application. Now, once we deploy the application, we then create the gateway and the routes for our application so that the app.kubesimplify.com is configured at HTTPS. And then we install ArgoCD, and we also try to configure a route for ArgoCD. For that, there was a specific insecure flag that needs to be added to the config map, and then restart of ArgoCD. And then we create a service monitor and scrape the custom metrics that we exposed. And post that, we created a visualization in the Grafana dashboard. After that, we did the load testing using K6 and created a HPA so that we can see the auto scaling when the load comes in. So I hope this project gives you some insights on what it looks like actually deploying a 0 CVE application onto a Kubernetes cluster and making sure all the pieces are fitting together, including the monitoring and 0 CVE for the base images and the application that you deploy onto the Kubernetes cluster. After this, there are a lot of things that you can do. You can have multiple Kubernetes clusters, and you can have multiple applications. You can have a highly available monitoring setup using Thanos built in. And you can also have a different application like Potato Head, try to deploy that and scale that and do different things. So your learning doesn't stop here. This is just a sample DevOps project with a complete end-to-end CI/CD cycle, HTTPS, DNS entries, and stuff like that. And also the use of Gateway API and CloudNativePG to showcase how you can run things in production. I hope you like the video. A few things in order to support the work that we have done in building this project for you is by sharing as much as you can. Fork the repository, add everything what is missing to the repository, try it out, raise issues, and also share as much as you can within your network, and subscribe to our YouTube channel as well. Also, all the commands used will be available as a gist, or I'll put in the README, and every link will be in the description of the video. Thank you so much for watching. If you have any other requests, please feel free to add in the comment section. Thank you.